So when it comes to list 28, we're going to take a look at another one of the rules that we have for identifying triangle congruence. Triangle congruence is identified by, can be identified by side, angle, side. We've already taken a look at one that was side, 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 in that all three sides of a triangle were exactly the same. Now what we're going to be doing is taking a look at side, angle, side, and there's a reason why we say SAS. It is in a specific order, so we know exactly what that one is. So what it means is that we've got two sides in the included angle. Now when we identify the included angle, let's take a look at this here. If I am looking at, say, side BC, and I am taking a look at side CD, what is the included angle for that? Well, that would simply be angle C, because that is the angle that is formed by those two sides. Now, if I want to know what the included side of angle A is, so I'm looking at angle A, which is right here. What are its included sides? Well, that would have to be here and here. So that means the included sides that make up angle A would be side AB and side AD. If I wanted to take care of B, that would end up being side BC and side AB. So the angle is always formed by the two sides that create it, that come together at its vertex. So, I'll give you a moment here, and I want you to make sure that you have this one written down into your little book. All right, so again, it's making the statement if two sides and the included angle. Again, remember that the included angle is the vertex at which those sides meet. If that is identified congruent in one triangle to the same items congruent in another triangle, then we say that those triangles are congruent by side and side. So, let's take a look at this. Are these congruent by side and side? And the answer is no. When I take a look at this, the angle that is identified here should be over here, correct? But since we're not given that information, I cannot go and say that these two triangles are correct, or congruent. Now, part of this is looking at, well, gee, it has, this side is congruent to that side is congruent to that side, that angle is congruent to that angle. So it has two sides and one angle congruent, but they are not in the correct order. They must be in the correct order, otherwise this does not work. So, and this is not. Check this. Finding a missing angle. First offhand, I need to know, are these triangles congruent? So I've got this side congruent to that side. This side is congruent to that side. So, these sides are congruent, these sides are congruent, the angle that is formed by those two sides are congruent. So yes, I can go through and do this now. So that means that 6x minus 27 is equal to 4x plus 7. One is on one side, one is on the other. Now we simply use our algebra to go through and solve. And again, when you're doing your assignment, you have a problem like this, I expect to see this work. If I see 17 on it, the assignment is incorrect. The assignment is to be redone correctly. That's how this goes. So please make sure that you understand this. So, here we go. We are to make a two-column proof. It says triangle, make an X on the design of this bar door. Use the side angle side postulate to write a two-column proof. So, start off here. We've got AB, and a lot of times it's very helpful for us to go through and draw it out, put the marks down so I know what I am looking at. So it says AB here is congruent to what? DC. So these two are going to be congruent. Now that's all the information that I have been given. So, start this off here that segment AB is going to be congruent to DC. And that is, of course, given. Now, I need some other pieces of information here. What else do I see in here that we've got? I was only given that, but am I given anything out of the picture? Anybody see something that's in the picture that we might be able to use? The angles. If I look at what this is right here, this is a right angle, correct? This is a right angle. Okay. Could I consider AD to be, I can't think of the word. Where the line intersects two other lines, so transversal. So AD would be the transversal for AB and DC, correct? Are those angles exactly the same? So, does that mean that AB is parallel to DC? Will that help us? How so? Could help me get to the next step. But what is it that I want to try and prove? That is also one of the other things that I want to have. I am supposed to identify that triangle ABD is congruent to triangle DCA. Now, my reason why I'm asking you this is when we look at this, are you looking at the small triangles or the larger triangles? Because we've got triangles that are going up through here, triangles that are going up like this. So we need to identify, would probably be a very, very good idea right now as to which triangles that we're working on. This is again why I say a picture is something that you need to have in your head. So, one triangle is supposed to be ABD, so it goes from A to B to D, and it goes back up. Now, I want the other triangle, which is supposed to be from D, C, to A, to D. Okay. Now, if I am looking at this, this gives me a better idea what I have to go for. Now, we said that these angles were the same. That's great. Okay. We kind of said, well, maybe parallel lines, that might be useful. But we're supposed to use this idea of side angle side. So, this side we said is the same as that side. We can also go through and make the statement. I'm going to kind of erase things here a little bit. we are also going to make the statement that angle A is congruent to angle D. I could say given, but that really wasn't it because he didn't really give that to me. What do we know about A and D? They're what kind of angles? Right angles. Did we have a postulate or something that talked about right angles? Well, I got one question. Are all right angles congruent? Okay. All right angles congruent. Okay. So now, what I've managed to come up with, I have a side. I have an angle, and an angle. In order for me to use side angle side, I need one more side, correct? Now, mind you, we said that this was one triangle from A to B to D to here. We said the other triangle was coming down here, going across there. Is there anything that we see now that we might be able to use? I'd really like a third side. So the third side looks right about here. Is this side on both triangles? So if we look at that, I can go through and then say that that side AD is congruent to side AD. Now you're looking at this and going, well, of course AD is the same as AD. But we have to understand that AD is on one triangle and AD is on another triangle. We had gotten this rule a long time ago. If something is equal to itself, we call it the what property? What do you see when you look into a mirror? Reflection. It's the same thing as what your face is, right? So this we could just say is reflexive. So now, what I can do is I can say that triangle ABD is congruent to triangle DCA by what? Side, angle, side. Because I have two sides that are the same, I have angles that are the same, and I have another set of sides that are the same. Again, that's what the column proof looks like. Is everybody going to do it this way? Not necessarily. But these are the things that you have to look for. If you are using a specific rule to solve, you want to look for those things. So, let's try this. An artist is designing patterned wallpaper made of congruent triangles. He starts by drawing triangle ABC, shown below. He wants the design to mirror the image of triangle ABC as shown in EDC. How can he make sure that his new triangle is congruent? So what would it require in order to make sure that this was going to happen? What has to be true? Now, I don't want you to sit here and look at this in terms of, oh, I got to figure out what's got to be congruent to what. If you were going to draw this out and you wanted to have triangle ABC and triangle CED to be exactly the same, what would you try and do? You heard somebody muttering something. What would have to be true? Very simple. So you guys think math's got to be a lot harder, but it's really easy. Okay, so I draw it out. How do you want me to draw it out? What should I make sure about when I draw it out? That it's what? Okay, so what would I use to make sure that something was the same as the next? Okay, why would you want to use a ruler? Exactly correct. So would I want to make sure that the measure from A to C was the same as from C to E? Would I want that to be true? Okay. So what I'm looking at here is I'd have to know that AC is congruent to EC, right? What else would I have to make sure of? Okay, we'd have to do the same thing for BC and CD. Okay, so I've done that. Is that all I need? Well, if I'm going to use this rule of side angle side, I've got this side the same as that side, this side the same as that side. What is the next thing that I need to make angle C? So is this going to be the same as what's over here? Angle C is going to be congruent to angle C, and we know that because it's a vertical angle, right? So you don't necessarily have to think super difficult about this. Look at it and say, okay, what do I know? What needs to happen? If you can come from that perspective, it makes life a lot easier, and it leads you to saying, okay, hey, what has to be equal? What has to be this? It takes care of the next question. So I'm going to give you a minute here and let you figure out whether or not this is. Are they congruent? Are we sure? If I take a look at the marks, I've got this one here is the same as this one over here. Got 2 here and 2 here, and the angle that's between these two is the same as the angle that's between these two. So yes, it must be. This one, all you just say yes. Because they just want you to, it's a yes or no question. Determine whether they are congruent by the SAS postulate. Now, these things could have been congruent, but not by the SAS postulate. So you got to make sure you remember, you read the whole question. So, let's try this. Give you a minute or so here. Okay. We need to find the value of x that makes the triangle congruent. So, let's... Ty, what did you get for x? So you got x was 20. Let's see how that worked out. Are they equal? Okay, because I got this identified with this, that identified with that, and the angles in between, so good. So that means we got 3x minus 12 is equal to 2x plus 8. Let's see, add 12, add 12, subtract 2x, subtract 2x. So I have x is equal to 20. Am I done? Did it ask me to go through and find the degree measures? No, it did not necessarily do that. My question for you is, would it be a good idea to always go back and do that? Probably. It'll be good practice for you. So while the answer was looking at x is 20, sometimes you don't know they want you to go through the whole thing. Also, that'd be just 2 times 20 plus 8, so we'd end up with 48. All right. Let's give this one a try. Give you a couple of minutes. Think about this one. See what you can come up with. Quite often when I'm doing problems like this, I always want to look and see it, what I know what do I need to know in order to answer the question? I don't attack it right away and say, hey, let's see, I got to create a column for two-column proof, and this and that. We want to identify that the triangle that is right here, WXY, this triangle here, is congruent to the triangle that's over here. Now, I'm just looking at this thing. I know that I've got this congruent to this, right? I know that I've got this congruent to that. And I know that I'm supposed to use this idea of side angle side. So I've got my side, I've got my angle. What side would I need to get congruent? WY. And now, have I really written anything out? No, I just kind of drew out the picture, looked at what it was that I had. Now I've got an idea of what it is that I need. So, back up here, and I'm going to start in with the two-column proof bit now. So, let's see, I'm supposed to prove that if that and that. So those are my givens. So we are going to say that WZ is congruent to WX. Y. We are told that angle ZWY is congruent to angle XWY. Y given. We know that we wanted WY congruent to WY because it's in both triangles, right? Now, as I'm going through this, if I got to have the same thing congruent to the same thing in a different triangle, we know that that one's the what one? Reflexive. And that means that triangle WXY is congruent to triangle WZY by what? Side, angle, side. That's it. If I have those pieces, then I can go and make a mistake. Well, let's see. I'm going to give you this one here, and I want you to do this and give it a couple of minutes to read through it and think about what is going on. So has anybody got a thought on this one? Cameron, what you think? What don't you know? Sorry, you know something. Did you read it? Okay, so land dispute over two triangular parcels of land can be ended by showing that the parcels have the same size and shape. In the figure, it says two sides of each parcel of the land were measured. It was found that C is the midpoint of both AD and BE. So if I've got a midpoint there, what does that tell me about the segments that are left when they're cut up? If something's a midpoint, what does that tell me? If I said that we were in the midpoint of the school year, what does that mean? In the middle. Okay? But it means something by far more than just the middle. The midpoint means that what was before it is the same as what is after it. It means that it's been cut into exactly two equal places. So if BE has been cut into two equal places, Cameron, what two things are the same? If I cut BE in half at C, what two things are the same? And what? You said C and E and what again? Nope. If I take D and E, if I go from here all the way over here, okay, and C is in the middle of this, cut it in the midpoint, which two things are going to be the same? Measures of what? The what? Which segments are the same? Yeah, there you go. So we know that BC is the same as CE. Okay. So let's try this. Kara, what else do I know? AC, you say? And what? Not E and D. Oh, C and D. Okay, so A and C and D are the same. So if I've got those two sides congruent, what is the last thing that I really need to have? Angle C. And why would angle C be the same? Not reflection. Because we're talking about this angle that's over here and this angle that's over here. Vertical angles. So, by side, angle, side, the triangles have to be the same. All right. I'll let you get to work on this.